Hello, my name is Bob Niels, and welcome to Introduction to Database Design. Now that we got past the introductory part of the course, and you now have a decent idea of what it is we're going to accomplish in this course, it's time to get started and start doing some of this stuff. To begin, what we need to do is kind of step back for a second and make sure we understand what database design is all about. And with that, what are the steps to getting there? And in the end, what is it going to look like when we get there? For this particular week, we're going to go through a series of videos that will talk about these steps and review the first couple of them and let you start practicing this whole process. For this video, though, our goal is pretty simple: to understand what our ultimate goal is. In the end, when we know we're finished and when we feel pretty good about we're done with creating a good, efficient, and effective database. So with that, what is a database design? What is a good database design? And finally, what is the database design process that we're going to adhere to in this course? This particular slide you've seen before. For the most part, as you see, this is an Excel spreadsheet. And we talked about this a little bit before in regards to some of the inefficiencies when it comes from this particular set of data, or this database, if you will, where we have a student and we have courses. And of course, when we look at this, we can see that a student can only take 5 courses. If they took 6 courses, we would have to add another column. Though that's not a big deal, but it becomes a big deal for every time we need to add a course for somebody. This could go on forever. Thus, this particular database, or this flat file system Excel, does not have scalability that we need. It provides a true inefficiency to be able to add and create and grow, along with trying to search to see what maybe courses have been taken by each student. In addition, you'll see here there's inefficiencies around the word male and gender, where we have male and male. I didn't do that. I did that on purpose, by the way. So with that said, how could we search for all the males in the course if somebody decided to spell male M-A-I-L? So with that said, that's what we're trying to fix. We're trying to get a database that eliminates all of that. Let me go back for 1 second. And not only that, it eliminates a lot of the redundancy that you'll see within the database. Particularly, you see that's all redundant data over and over again. Instead of having redundant data, why don't we represent it one time? So in the end, our ultimate goal is a database that's scalable, a database that's accurate, so we don't have this kind of data sitting there, and a database that eliminates redundancy, so it's a very efficient database, and it's one that can be easily searched. Does that make sense? Again, I know we're really early in the course, but just keep that in your back of your mind. That's where we're headed with this, and sooner or later it'll click, and you'll see how all this comes together as it kind of goes. As I mentioned before, our ultimate goal, scalability, eliminates redundancy, one is correct, accurate, and complete, and one that's going to be easy to access and get information out of. Really important. People want information and they want it now, so they can't afford to wait due to an inefficient database. To get there, to actually create this efficient and effective and scalable database is a process. It's a process we're going to practice continuously throughout this course, but it's a process, and it's going to be one that's going to be easier and easier to you the more you do it. And again, there's a lot of steps to it. Not a lot, but there's a few steps to it, I should say. One that that we need to go through. Some of them could take a long time based upon the scale of what we're actually trying to accomplish. Or it could be something that you could complete in a matter of hours or an afternoon. I've been involved in both situations where developing a database took over a year or so, just because of the requirement gathering that we'll speak of here as we move forward. Anyway, this process that we talked about is database design. So the fact that this course is called Database Design in SQL, we're going to be focused on database design during the first couple weeks here as we kind of get started. So what is it? I took this from Wikipedia. Database design is a process of producing a detailed data model of a database. I said, all right, I like that. Well, what the heck's a data model? Well, a data model is that it organizes elements of data and standardizes how they relate to one another and to the properties of the real world entities. Wow. What does that mean? Basically, what we're going to be doing is we're going to create entities. We'll talk about that as we progress this week. Not create entities, we're going to identify entities, I should say. And then we're going to identify the relationships of these entities. And in the end, we actually have a database. If you just kind of keep that thought for 1 second. So it's a model that basically shows these relationships between all these entities that in the end represents a database. Hold that thought for 1 second. We're going to talk about the steps a little bit more that might make this a little bit more understanding when we get to it. Okay? The process of doing database design consists of a number of steps which would be carried out by the database designer. The designer must determine the data to be stored in the database. That's pretty obvious. Determine the relationships between the different data elements. We'll talk about that in grave detail. And superimpose a logical structure upon the data on the basis of these relationships. So a logical structure is one that you can see, but you can't really touch. But in this case, that we actually put it together in a way that these relationships are then made and instilled in the database to make it for, once again, easy access and easy understanding, scalability, efficiencies, and so on and so on. Once again, I sit back and think about where we are right now with the course and this terminology that I'm throwing out at you. I can see probably some of you shaking your head going, what is he saying? What are we trying to accomplish here? I don't want you getting too caught up in all the terminology right now and too worried about it. Kind of trust me at this point in time and just kind of hang in there a little bit as we go through the process. And I think some of this will be clarified as we go through it. I welcome you to listen to this video a couple times as we move forward, maybe going back, and I think all of it starts making a little bit of sense. Okay? Once again, we're going to walk through these steps piece by piece in regards to what database design is, and then maybe that might help. So what is a good database design? We kind of said it over and over again, but it's a good cause for repeating it to make sure you truly understand. It divides your information to subject-based tables to reduce redundant data. Well, once again, so what the heck is a subject-based table? We'll talk about that as we move forward. It provides your DBMS. You should know what that is now, with the information it requires to join the information in the tables together as needed. Once again, what's a table and what do we mean by joining? Well, we're going to kind of break things apart in a way, and we need to bring it all back together again when the information is needed. We're going to break things apart for the sake of efficient storage, then we need to join it all back together again for the sake of quick and easy information coming out of the database. And so it helps support and ensure accuracy and integrity of your information. Going back to that MAIL in my Excel spreadsheet I had on the first slide here, that won't happen if we design our database correctly and efficiently and effectively. It accommodates your data processing and reporting needs. And so a good database design makes sure that we can get the information out that is actually needed. And we'll talk about that a little bit more as we get into the requirements piece of this database design. Excuse me. So what is this design? What's our steps? I'm going to walk through each one of these a little bit, kind of talk about them a little bit. Hopefully it'll get you an idea of where we're headed with all this and how we're going to really kind of go through the course, at least for the next few weeks. So anyway, we're going to determine the purpose of your database. To start a design, you got to know what it is you're doing and why you're doing it. We're probably going to write a mission statement on it. We're going to say this database is going to do this. And so we all understand ourselves and we all understand what we're doing and why we're doing it and what the purpose is. We're going to collect, find, and organize the information needed in your database. This is also known as collecting requirements. As I mentioned before, this requirements gathering can take anywhere from an hour. Heck, I worked on projects where it took a year, all based upon the complexity of what we're actually trying to accomplish. Usually what's happening when you're creating a database, especially from a software developer point of view, you're not just creating the database, you're developing a complete application. And the database is part of that. So with that said, you're collecting requirements to actually understand how to build this entire application. So once you get those requirements done, one of the first things we do from the design phase is then develop the database, along with developing screens and developing the architecture in which all this is going to reside. So this is really database design for the most part from a software developer point of view, really is part of the design phase, I should say, the design phase of the system development lifecycle, which is the life cycle from an idea all the way through implementation of a software development application. Does that make sense? For this particular course, obviously we're not building applications, but we will develop our databases based upon requirements and start getting you used to that. There's going to be subsequent courses that I'll mention here later on called Systems Analysis and Design that actually helps define this whole system development lifecycle. That might make all this a little bit more sense, make more sense for you once we get to those points and once you kind of get out there and start doing more programming and everything else. Again, this is one piece of the entire system development lifecycle and one piece of a software application. Once we get our requirements, what we're going to do is go out and identify these entities from your requirements. We're going to divide your information into these major entities, which are entities are a person, place, or thing, or an object. Yeah, we'll stop there. That's just basically these nouns, if you will, that we gather from our requirements, and we're going to identify all of those. I'm going to take you through a process in a different video that will show you how to go about doing that. Some examples, products or orders, maybe from like an Amazon type of environment. Once we identify all these entities, we're going to identify the relationships between the entities, the direct relationships between these entities. They can either be one-to-one, one-to-many, or many-to-many. What does that mean? Well, when we're designing our database, we're designing a relational database. We already talked about what a relational database is. With that said, these relations between these entities, aka the tables that we're going to create in our database, are either going to be one-to-one, one-to-many, or many-to-many. There's no other types of relationships. That's those three, which in a sense should make it easy. There's only three of them. We just got to figure out which ones are which. By the end of this week, you'll be practicing this. If you notice the ones, I put a little asterisk next to these things that we're going to be covering this week. So if I go back a slide, you'll see we'll be covering these four things or these four topics this week as it relates to the database design process. In subsequent weeks, next week and so on, we'll be discussing the rest of these phases. So what are those? Once we identify the entities and relationships, we identify the attributes. What makes up these entities? What are the characteristics of each entity, if you will? We're going to decide what information you want to store about each entity. For example, a student entity might include attributes such as last name and gender. There's other ones, address, GPA, I don't know, social security number, student ID possibly. These are all attributes that make up and identify that particular entity. We'll talk about that again in subsequent weeks. We're going to identify the data types of each attribute. It's very important in database world that we tell the computer exactly the data type that we're dealing with. For the most part, it's relatively easy. It's either an alphanumeric character that we call a string, or it's a numeric character, such as an integer or a decimal. There'll be a lot more to talk about when we get to that. And as a matter of fact, data types aren't just, we would say solely talked about in database world. They're also talked about in variable world as we relate to programming languages. So you'll get a lot of information about data types and its importance to the overall process of developing software. We're going to get into primary keys. Once we have all this taken care of and we know our attributes, we're going to get in and identify a primary key. I don't want to go too much into this. It really starts talking about the logical structure of a database, but we'll talk a lot about primary keys. After that, we'll get into forming relationships between entities utilizing these primary keys and forming what's called a foreign key, which is actually your primary key in a different table. If that went over your head, no worries. Just kind of telling you what's to come. But we'll tell you how to do all this. Once we're done with all this, once we have defined all of this and designed it all, we'll finally go out and start building our database, which we'll do in this class. We'll get in a SQL Server and we'll start building the databases. And we'll do that by making all our entities into database tables. And we'll talk more about what a table is. We'll make all our attributes into columns of the table. We'll build the relationships with the primary and the foreign keys. We'll insert data in these tables and test the data. Based upon how it all works, we may refine our design if needed and move on. Okay? Once we're done with all of that, we go into what's called normalization. These are the 3 rules of normalization we'll review in this course. First, second, and third normal form, they're called. We'll go into the definitions of each one, but basically what we're going to be doing that these normalization rules help ensure that our database is well designed and then thus provides the efficiency, the lack of redundancy, the scalability and everything else that we talked about and which we're trying to achieve in this process. And again, we'll spend a few weeks or more on the normalization project. Okay? That's where we're headed. That's what this video was all about. Basically, kind of outlining what it is we're going to be accomplishing as we move forward in these next few weeks and so on, really. I should say the entire course. We're going to focus on it the next couple of weeks, but we're going to practice it the entire course over and over again. All right? So with that said, let's get started with the first steps. Take care.